Now, one more mini project which I am going to discuss about is UDS communication project using vector ETAS tools. Okay. Now here is a detailed practical case study focused on implementing unified diagnostic services, communication using professional tools like Vector Cano, Canalizer, or ETAS Inca. Inca, as I said, is a very important or very popular calibration tool widely used in automotive industry for ECU diagnostics and testing. Now talking about the case study, UDS communication project using Vector or ETAS tools. Okay, talking about the project objective to develop and validate diagnostic communication with an automotive ECU using UDS protocol over CAN using tools like Vector, Cano, Canalizer, or ETA Inca. All right, this is what I touched upon previously, and the project includes what is the objective of the project to establish UDS over CAN communication, sending standard UDS service requests, and receiving decoding ECU responses, logging and analyzing communication sequences. Now automatic test cases for ECU diagnostics. All right. Now talking about the tools and equipment. What are the various tools? Vector Cano Canalizer for bus monitoring and UDS communication. Vector VN1610 for CAN interface hardware. ETAS Inca for measurement, calibration, and diagnostics. ECU target to test UDS communication. ODX or ARXML files, diagnostic description files, and capable CAPL scripting, Cano automation and test sequences, CANDB network database for CAN signals, and UDS service reference ISO 14229 documentation for service details. Now talking about the protocol overview. What are the various protocols and what are their corresponding respective descriptions? First of all, UDS, as everybody knows, ISO 14229, diagnostic communication protocol over CAN, and CAN ISO 11898, physical and data link layer, and ISO 15765, transport protocol for message segmentation, and diagnostic services, service IDs for reading, writing, and session control. Now, talking about the key UDS, key Unified Diagnostic System services used in the project. Now, these are the service names: diagnostic session controls, the ECU reset, the security access, data read data by identifier, write data by identifier, clear diagnostic information, read DATC information, and communication control. Now, these are the various service names that are included in this project. Now, as you can see on the right side, this is the service identifier and also the purpose. So I request all of you to pause the video and thoroughly try to assimilate this the information which is presented in this table. Okay. So to proceed further, now what is the use case scenario? We'll talk about one use case scenario. So the purpose of this scenario is read and modify vehicle identification number. First is start communication, open Cano or Inca with correct CAN interface configuration. And next is enter extended session. Send UDS service with the help of this kind of with commands like TX1003 or X5003. All right. Next comes the security access, and within security access, you send commands, you receive commands, you calculate the key using algorithm. Again, you send, you receive. Next, you read the VIN number, write new VIN number, ECU reset, verify VIN after reset. All right. Now, talking about the Cano project structure. Now, exactly going into the Cano and explaining Cano is beyond the scope. For now, you understand that Cano is a tool which, if Cano is a vector tool, and with the help of CANDB, include network DBC for message interpretation, diagnostic layer, load ODX file or manually define services. And when it comes to panels, graphic user interface to trigger UDS requests, and talking about the CAPL scripts, which is an important script as far as Cano is concerned, automate diagnostic test sequences, seed key algorithm for security access. I clearly explained to the importance of seed key in one of the previous one of the previous lessons. Trace window, view and filter UDS traffic, measurement setup, log communication and generate reports. Now talking about the Inca project structure, load ECU description A2L or ODX, create measurement and calibration setup, and use UDS service tool, manual service requests, and also store request response pairs. Now talking about the log and visualize responses, perform analytics and DTC's reset behavior, parameter changes. So these are the Inca project structure. If at all you are using ETAS, this is the step-by-step structure of the Inca project. All right, and now what is the project flowchart? First you start the project, next you configure the CAN interface, which is a very important step. Next you establish the UDS session with the ECU. Next unlock ECU with the security access. Perform diagnostic functions, whatever functions like read, write, clear DTCs. Next log responses and validate and automate with CAPL or Inca scripting. Now this Inca scripting and CAPL scripting are extremely important for automation. And finally you generate the test report and end, and then you come to the end of the project. Now talking about the validation criteria, these are the criteria and these are the success metrics. All right, first criteria is UDS connectivity, and the success metric is ECU response to the service identification. Next is session switching. ECU enters and confirms requested session. Security access, correct key unlocks secured services. Data read, correct response to 0 by 22 requests. Data write, win or parameter successfully written. And DTC management, DTC's read and clears correctly. And talking about the automation, now again, let me emphasize the automation because this is the exact step which saves a lot of time. CAPL scripts run end-to-end test. Now challenges and mitigations. First challenges is the security. Of course, we have solution like correct seed, key algorithm, validate and timing. But even the solution sometimes may not be foolproof. But most of the time this serves a purpose. This does the job. Now next coming to session timing out. Maintain periodic keep alive messages. Incorporate a transport layer. Implement TP correctly multi-frame messages and parameter ID known. Validated ODX, ARXML support or reverse engineer IDs. DBC, ODX mismatch and update or regenerate description files. Now these are the challenges and solutions. So the final outcome, the learning outcome of this entire project is you clearly understand the UDS services in depth, and again you gain experiences on CAN tools, you gain hands-on knowledge on ECU communication and diagnostics, and you are exposed to CAPL scripting, ISO TP, session protocol, and seed key access. Real world application of the vehicle diagnostic standards. Okay, so these are the learning outcomes, and what whoever is the project implementer, he will learn all these things. Okay, thank you.